Moment of inertia. Define. Moment of inertia, I, is product of mass and square of its perpendicular distance from axis of rotation. Formula is, moment of inertia, I, equals mr superscript 2. Unit is, kilogram meter square. Dimension is, ml superscript 2. Importance. Moment of inertia plays same role in angular motion as mass plays in linear motion. Moment of inertia resist the change in angular rest or uniform angular motion. Derivation. According to Newton's second law, force F equals ma. As, acceleration, a, equals r alpha. So, force equals mr alpha. By multiplying r on both sides, Rf equals mr square alpha. It is equation number 1. As, Rf equals torque. So, equation 1 becomes torque equals mr square alpha. It is equation 2. As we know that moment of inertia, I, equals mr square. So, equation 2 becomes torque equals I alpha. It is equation 3. Equation 3 is the angular form of second law of Newton. Moment of inertia of a rigid body. A definition of rigid body. A rigid body is an object that doesn't change shape or size when forces are applied. For mass m1, torque 1 equals m1 r1 square alpha. For mass m2, torque 2 equals m2 r2 square alpha. For mass m3, torque 3 equals m3 r3 square alpha. Similarly, for mass mn, torque n equals mn rn square alpha. Now total moment of inertia. Total torque equals torque 1 plus torque 2 plus torque 3 plus up to so on plus torque n. By putting values. Torque, sad face, m1, r1, square alpha, plus m2 r2 square alpha, plus m3 r3 square alpha, plus up to so on plus mn rn square alpha. It is equation 4. As alpha is same for every mass. Now, torque equals n summation, I equals 1, m, I, r square, I, alpha. As, n summation I equals 1, m, I, r square, I, equals moment of inertia, I. So, torque equals I alpha.